So in this example, we are going to graph f of x equals x squared minus 4x plus 8. First thing we're going to do is we are going to identify the a value, the b value, and the c value. So if I look over here, this is my a. I don't see anything in front of the x squared, so my a value is 1. Your b value is always the coefficient of the x term, so that's going to be -4. And my c value is always the constant. It is the value that does not have a variable attached to it. And we're going to find the vertex and the axis of symmetry. And this is what we did yesterday, and we started out with a warm-up today, finishing that up. So again, you're going to start out with that axis of symmetry formula. H equals the opposite of B all over 2A. And I'm just going to plug in my values. Now be careful here. Remember, this is a negative b. And your b value is -4 all over 2 times a, which was 1. So we have a -4, which makes this a +4, divided by 2. Okay, so my h value is 2, so that is the x value of my vertex. Now I need to find the y value, which is also the k value of the vertex. So all I need to do, if I know x, I can plug x in to my original function to pop out that corresponding y. So we have f of 2 equals 2 squared minus 4 times 2 plus 8. And 2 squared is 4. -4 times 2 is -8 plus 8. We can see here -8 plus 8 is 0. I'm left with 4. So my vertex is 2, 4. And let's make a note here. My axis of symmetry is x equals 2. And you know what? Let's just go down to the graph. Let's start doing this as we go. So I'm going to scoot this up here. And I believe I can do this. Yes. I'm going to scale this 2, 4. I'm going to scale this by 2s. 2, 4, 6, 8. And we'll do this by 2, 4, 6, 8. Everything is going to be scaled by 2s. So my vertex is at 2, 4. Let me get a red pen. Is at 2, 4. And don't forget your axis of symmetry. That's that invisible line that divides your parabola into 2 symmetric parts. So we'll say that that is x equals 2. Okay, so that's what I know so far. Let's go find the y-intercept. So remember, if you are on, let me pull that back up again. If you're on the y-axis, your x value is 0. Okay, we haven't gone left, we haven't gone right of the y-axis, so your x value is 0 if you're on the y-axis. And again, we know, if we know an x value, we can pop that value back into the original function to get the corresponding y value out. So if we look at this as f of 0 equals 0 squared minus 4 times 0 plus 8. Well, notice when you do that, your first term, your square term, that goes away. Your middle term goes away. All you are left with is that c value. So what's really cool about standard form is you can automatically, just by looking at the equation, know what your y-intercept is. It will always be that C value. So let's make a note.
It will always be the C value?
It will always be the C value, because if you think about it, when you're substituting in 0 for x, okay, anything in standard form, any term that has an x in it goes away. So then all that's going to be left is that C value. So notice the y-intercept is the C value, and that will always be the case.
Excuse me.
Yes.
May you move it up, please, so I can see step 1 again?
Okay. So we are going to graph this. I am recording, so I'm going to go ahead and move this up. We'll come back down to it in a minute. So here we go. We're going to graph that y-intercept. So I am at 0, 8. Here's my y-intercept. Now, if your y-intercept, I made the note here, I don't really know how often it's going to happen. Really, because if your y-intercept is going to be the same as the vertex, chances are you're going to be in a form that you can graph a little different way. But if your y-intercept is the same as the vertex, you would just choose a different point. So you could just come along whatever x value, I'd keep it close to your vertex, pop it in and get another y value out. That's all you do. So now what we're going to do is we're going to find a point symmetric to the y-intercept across the axis of symmetry. Let's go ahead, let's label this. This was your vertex at 2, 4. Here's your y-intercept at 0, 8. And we have this axis of symmetry. Now remember, that axis of symmetry divides that parabola into 2 symmetric parts. So if I have a point on this y value of 8 that is 2 units from the vertex, I'm going to have another point that is 2 units, or excuse me, from the axis of symmetry, 2 units to the right. I now have 3 points, and that's really all you need to graph a quadratic. And again, this is a nice rough draft. We have the key features in here. So there is your graph.